Today, as we look at section 4, we're going to look at the volume of prisms and the volume of cylinders. So, we'll start off with the volume of prisms. There's really only two equations you need to know, the first of which you see in front of you. It says that the volume of a prism is equal to the area of the base times the height. So a much simpler equation than what we were using in section 2 and section 1. So if we were to do this, we would look at the volume and we would take the area of the base. Since it's a rectangle, the area is just length times width, or 24 times 20, and the height is 10. So if we worked it out, 24 times 20 is equal to 480. So the volume would be equal to 480 times 10. Or in this case, the volume is equal to 4,800 centimeters squared. As we saw in section 2, not all prisms have a square or rectangle as the base, so some have to do with a triangle. And remember, the height is the distance between the two parallel and congruent sides. So in this case, the bases would be this triangle and this triangle down here, and the height would be 10. And so, in order to find the volume of this prism, we must find the area of the base right here, or right here, and multiply it times the height. In order to do that, though, we must turn the prism and look at just one face. We have to pretend that nothing else exists besides that one face. And this tells us that it's 8 inches here, here, and this can be brought over here, so this would also be 8 inches. So when you turn it on its side and just look at the base, you have an equilateral triangle. And when you have an equilateral triangle, all angles are 60 degrees. So you have a 60-degree angle here, here, and up here. But when we draw a angle bisector down to get the triangle, or the height of the triangle, it creates a 30, 60, 90 triangle. And so the apothem ends up being, or the height ends up being 4 times the square root of 3. So in order to find the area of the base, we must use base times height for a triangle. So the area is equal to 1/2 base times height, which we just found as area is equal to 1/2 times 8 times 4 root 3. 1/2 times 8 is 4, and 4 times 4 is 16. So the area of the face is equal to 16 root 3. Now when we go to find the volume, we found out the volume is equal to the area of the base, which we just found is 16 root 3, times the height, which as we see up here is 10. So 16 root 3 times 10, or the volume would be 160 root 3. Now if I asked you to leave it in terms of simplest radical form, you would leave it like that. Otherwise you would rotate, or you would plug into your calculator and get the decimal as 277.12, or around there. The second equation we'll be looking at is for the volume of a cylinder, and as you see above, the volume of a cylinder is going to be equal to pi times the radius squared times the height. So if we take this example from your book, then the volume is equal to pi times the radius squared, which in this case is 3. So 3 squared times the height, which is 8. So volume is equal to pi times 9 times 8, or 72 pi. So it's the same in theory as the volume of a prism, just this one deals with pi r squared. The last part of section 4 deals with taking irregular figures and finding the volume of the figures. It's similar to what we did on the test chapter or 2 ago, where we had multiple figures and we just added up the areas. So now we're going to have multiple figures and we're going to add up the volumes. So it's easier to just break it down into things that you know how to solve for. So if we draw a line right here, then we have it broken down into two forms, or two figures, like figure 1, we can call it figure 2. Okay, we know that this is 2 up here, so we can deduce that this would be 2 inches and this would be 2 inches. So if we want to find the volume of figure 1, so the volume of 1 would be equal to the area, which is 2 times 1 times the height, which is 2, or the volume of 1 is equal to 4, because 2 times 2 is 4, times 1 is 4. So we switch to volume 2. Now we have a base of 2 and a depth of 1, so the area would be 2 times 1 of the base, and the height in this case is 4. So it would be 2 times 4 is 8, times 1 is 8. So the volume of figure 2 is 8. So in order to find the volume of both things, you just add them together. So 8 plus 4 gives you a combined volume of 12 inches cubed, because volume is always in cubic meters or inches or centimeters or so on. So tomorrow we'll do a couple more examples, and then you will have a fair amount of time to work on your homework. So come to class if you have any questions, let me know and we'll answer them at the beginning of class.